Alright guys, it's Frank and today I'll be talking about concept 7.2, which is how glycolysis harvests chemical energy by oxidizing glucose to pyruvate. So first of all, glycolysis is also known as sugar splitting because that's exactly what it is. It breaks down glucose into two molecules of pyruvate. So glycolysis occurs in the cytoplasm and has two major phases: the energy investment phase and the energy payout phase. The energy investment phase is the first phase, and this is also known as the energy requiring phase. It's known as this because just think about it. If you invest energy into something, for you to be able to invest this energy, you need energy first. So you require energy to be able to invest it in something. And the energy payoff phase is also known as the energy releasing phase. So when you're paying someone back, let's say you owe them money, when you're releasing that money, you're paying them off. And as you pay them off, you're getting rid of that money from your hands. So the money isn't yours anymore, it's theirs. And when we look at glycolysis, you start off with a glucose, which is a six carbon molecule, and ATP is transferred from a phosphate group to form glucose 6 phosphate. And after that happens, glucose 6 phosphate is then transferred to form fructose 6 phosphate because these are isomers of each other. So then you get fructose 6 phosphate. And then another phosphate group is transferred from ATP, which causes fructose 1,6 biphosphate to be created. So now that we have fructose 1,6 biphosphate, knowing that it's unstable and it can't hold the whole molecule inside the cell, it then splits into two 3 carbon sugars. One of them is glycoaldehyde, and the other one is DHAP. These are isomers of each other, but despite that, only one of them is able to make it to the energy payoff phase, and that's DHAP. Let's keep rolling. So then we start off with glucose, like I said, and then once we have our glucose, energy transfers from ATP to form glucose 6 phosphate, and after that, glucose 6 phosphate is the isomer of fructose 6 phosphate, so it transfers over to become fructose 6 phosphate. And once we have fructose 6 phosphate, ATP is then again another phosphate group is attached and is transferred from ATP to form fructose 1,6 biphosphate. Because it's unstable, we get two 3 carbon sugars, and which are this right here and DHAP. And now we have the energy payoff phase. So the energy payoff phase, it starts off with glycine. So then the energy payoff phase, which is also known as the energy releasing phase, the second phase, like I said, and we start at this phase with G3P. I'm only using that acronym because I can't pronounce this. But regardless, we start off with G3P, and right here we have 2 NAD plus 2 NADH, and because there's in the initial phase G3P loses 2 electrons, it reduces the NAD to NADH, which is right here, and it produces a hydrogen ion. And when that happens, this molecule is formed biphosphate glycerate, and after that, ATP is then transferred to form phosphoglycerate, and the energy is used to form phosphoglycerate. And then phosphor 3 phosphoglycerate is then converted into its isomer, which is 2-phosphoglycerate. Once it's converted into its isomer, you have 2-phosphoglycerate. 2-phosphoglycerate actually loses a water molecule, which then causes it to become phosphorylpyruvate, also known as PEP, and we get another conversion of ATP, which then causes us to end up with pyruvate. So if we're going over the energy payoff phase one more time, this is the end of the energy the energy requiring phase, which is also known as the energy investment phase. And like I said before, only one of these can go through, and it'd be G3P. So once G3P goes through, we then have it loses two electrons and two protons, which then causes the two NAD plus to gain a hydrogen molecule, which then causes the two NAD plus to turn into two NADH. And then after that, we're left with 1,3 biphosphate glycerate, which is then which is which is a result of a donation from phosphate group to ADP, which then creates a new molecule. And then once we have that done, we have 1,3 biphosphoglycerate is then converted into its isomer, and we can see here its isomer, which is 2-phosphoglycerate. And once we have 2-phosphoglycerate, it loses a water electron, which then causes it to become PEP. And because PEP is unstable, it's probably going to lose its phosphate group in the process of glycolysis, which will then cause it to become pyruvate. So to review all of glycolysis, like I said before we start off with two phases, energy investment and energy payoff. So in the energy investment phase, we start out with glucose, which is 6-carbon molecule, and there's two phosphate groups attached to it. Because it's rearranged, the phosphate make a new sugar, which is fructose. And in that process, two ATPs are used and two ADPs are used. And from the investment phase, fructose is unstable, which indeed causes it to split in half to form two 3-carbon sugars, DH8P and G3P. And once we are able to figure out which one makes it to the energy payoff phase, which is G3P, we start off with the energy payoff phase. In the energy payoff phase, uh, in this, each 3-carbon sugar is converted into pyruvate, and while this reaction takes place, two ATPs and one NADH are made. Because it happens twice, we end up with 4 ATPs and 2 NADHs. Because for each reaction, it takes 2 ATPs and 1 NADH, and 2 times 2, you end up with 4 ATPs, and 1 times 2, you end up with 2 NADH. And as you can see here, we have 4 ADP and 4 ATPs are formed. So then the net worth of glycolysis, because we have 4 ATP formed and 2 ATPs used, we get a net of +2, because 4 minus 2 is 2, and we have 2 NADHs. So the net of glycolysis is 2 ATPs and 2 NADH. And that's pretty much it, guys. For glycolysis, we end up with 2 ATPs and 2 NADH, and that's it. See you guys tomorrow.